Souls, don't you? Usually we have, when we're handing them out to kids, we have to say, don't blow those, parents are going to take them away if you keep blowing those. Yeah, that's true. It's kind of like the parent, right? All right. Well, I do show it's 6:30. So are you ready back there? All right. So that's not what I wanted to happen. All right, let's go ahead and get started with your severe weather training tonight. To get us in the mood, I'm going to kick off a little bit of a video that's going to show you some just beautiful, scenic, not all Kansas weather, but Kansas type weather. So we're just going to watch this for a couple minutes and just get in that severe weather spirit. All right, does that make everybody just go, oh yeah, bring on storm season, right? No, yeah, that's kind of my reaction too. Let's just not do any of that, okay? All right. Well, as introduction, if you don't know me, my name is Carrie Cordles. I am the Director of Emergency Management for the county, which means that a whole bunch of my job has to do with weather, has to do with monitoring weather, reading about weather, writing about weather, watching the weather come in, helping to solve all the problems caused by the weather after the fact. And so that's part of the reason why we're so heavily invested in doing this weather training, is because it can be very impactful for our county, for our residents. Anyone in here not been through one of these Storm Fury classes before? Anybody new to it? Oh, awesome. We do have some newbies. Well, just to give you a little bit of a history, first of all, I did not make this presentation. I tweaked it a little bit. It was actually written by the National Weather Service office here in Wichita. They do one of these programs every single year. They've been doing it for decades, as far as I know, long before I started in emergency management like 17 years ago. But they do this program, they make a presentation, they go and they deliver it once in every one of the counties in their coverage area. And then for those of us that want to redeliver it, they give us the presentation and say, go forth and redeliver it. And when I get it from them, I may make a few little changes, adjust a few things, add some bonus stuff, kind of my own flair. But most of this is stuff the National Weather Service has put together for us. And they have pretty much a formula that they follow. So year after year, if you do a lot of these, you find that there's pretty much a standard structure. We talk about Kansas climate. We talk about our history here in Butler County, what kind of weather we've had. We talk about how storms are put together, the storm science, because knowing how a storm develops and what the pieces of the storm actually are can help you understand if a storm is getting really ramped up and about to become hazardous and about to drop a tornado on you or something like that. And then we also talk about reporting, because the original purpose behind these trainings was actually to train folks who were going to go out and be storm spotters, who were going to purposefully tangle with storms, to observe them, to report back what they were doing for purposes of public safety. So there's always a component on reporting as well. And actually nowadays, in the era of social media and basically everybody having access to a way to share what they're seeing and report what they're looking at, really everybody now is a spotter. It's not just those people affiliated with emergency services or affiliated with a TV station or affiliated with the NWS. And then we always wrap the program. There's always a section where we talk about just your basic storm safety. What do you do if there's a tornado approaching? What do you do if there's large hail landing, that kind of thing? So first of all, let's talk about Kansas's weather in general. I added this little intro slide that says a look at normal, but honestly, I don't know that our weather has a normal other than behaving abnormally. If you look at the fact that just in this month alone, we had the very first week of March, we just went all out on let's do storm season and let's do it immediately. And then almost right on its heels, we had a morning where we had -4 wind chills again. And then now we're like in the 80s and 90s. So, I mean, why not? We're not normal, but looking at kind of normal severe weather or what our patterns are for severe weather. First of all, would you all agree we are definitely a severe weather state? Yeah. There are people that out there, they'll rumble and they say, oh, Tornado Alley is shifting. It's not the plain states anymore. Now it's Mississippi, it's Alabama, it's Ohio, it's Georgia. They'll just pick other stuff and say, it's not where it used to be. It's all shifted east or it's all shifted south. Definitely, there are different patterns every year, but if you look at the numbers of how much severe weather does occur here in Kansas, actually, our meteorologists would say not only are we still in the center of it all, they say we're number one. So, woohoo, go us. What they're basing that on, because if you just took all of the reports from Kansas and compared that to all of the reports of weather in Oklahoma and all the reports in Texas, well, Texas is going to blow us away on landmass alone. They have a lot more space for stuff to happen. So what they did to really compare apples to apples is they said, okay, let's take a 10,000 square mile box. Let's just take a block of Kansas and do the same thing in our neighboring states and say within that block, how many significant severe weather reports do we get every year? So not just your pea-sized hail or your, little 40-mile-per-hour wind gusts, but significant. Like 40 is a light breeze. Tornadoes, golf ball or larger hail, significant wind gusts like 70 miles per hour or more. If you look at those significant severe reports, how many average within that 10,000 square mile block? We've got an average of 62 per year, which blows away our closest competitor, Oklahoma, by 10 reports per year. And then it just kind of goes down from there. Texas isn't even on there, but I think that's because they're not adjacent to us. But yeah, so the National Weather Service definitely believes we do severe weather, we do it really well, and we are at the top of the game. If you look at it from a watch perspective, so if you just say, okay, well, let's look at how many actual NWS products are issued every year and how do we shake out there? You can see right there in the plain state, that center of the country, we've got the really bright spots, and the scale goes all the way up from the white all the way up to the yellow, which is the top of the scale. And you can see all those yellows in the plain states that shows that's where the majority of the severe weather watches, tornado watches, and severe thunderstorm watches are issued every year. We get an average 15 to 20 per year in Kansas. If you can see from where you're sitting, does anybody see what color Butler County is? We're kind of in that top, kind of hazy yellow, not quite up to the full yellow, but yeah, we're right there at the top. So what do we get in terms of if we look at it from a warning perspective? What do we see? Was that you? Hey, we need our presentation back. Hang on, technical difficulty. Wait till my presentation comes back. That wasn't me. Hang on, we'll wait for the AV guy to catch up with us. All right, there we go. That looks a little bit better. Like, oh gosh, that wasn't one of my counts. So now, if you look at our tornado warnings and what we get on average for tornado warnings every year, on average, Butler County gets 2.1 tornado warnings per year. Now, tornadoes get all the headlines. They are the ones that get all the attention because they are so eye-catching, they are so dramatic, they do a whole lot of damage. But by comparison, the number of severe thunderstorm warnings we get per year is substantially higher. We get 33 severe thunderstorm warnings per year. So thunderstorms without the tornadoes are far more common than the tornadoes. And in fact, let's take a look at, and yeah, more common, just as dangerous. Let's look at last year. Last year, Butler County had 0 tornado warnings issued for us. There were definitely some hot spots in Kansas, and we definitely had some big tornadoes that happened last year, but not here. And since we averaged 2.1 tornado warnings per year, that meant that we were below average at 0, 2.1 below average. So, but how about on severe thunderstorm warnings? 54 severe thunderstorm warnings issued for us last year compared to our average of 33. So we were well above average here. Most of the state was above average. We were substantially above average. But going back to those tornadoes, those headlines capturing, those really dramatic events, what have we really had in terms of number and severity of tornadoes? This map has every tornado since 1950 that was reported and recorded. Now, if you think back to probably the 1950s and 1960s, people weren't out there tweeting pictures of their tornado or putting on Facebook, look at this tornado that went through my backyard. So we're probably missing a lot of tornadoes that occurred in the early end of that scale. Probably captured them a lot better more recently. But if you take all of the actual records the NWS has for Kansas since 1950, there were just under 4,600 tornadoes recorded. That seems like quite a lot. I mean, and they're speckled all over. Nobody really gets any kind of favoritism. But if you look at, and we're going to discuss the scale that they're measured on a little more in detail later, but you can see that the little blue dots, those are the lowest end tornadoes. So we got those little EF zeros. You can see we get a lot of those. And then actually, there is another rating for tornadoes. I don't know if you're familiar with the term EFU. Make sure you enunciate that properly, EFU, which just means EF, unknown. It was so brief, it was so weak, and it really didn't impact anything. So there was no damage, so they couldn't rate it. So a tornado might get a rating of EFU if they really have no way to base figuring out what the rating really was. But if you look at all of those little dots speckled all over the map, and you look at how many of those were in that low end, 95% of our tornadoes are EF zeros, ones, and twos. So most of our tornadoes are not the violent, the strong, the deadly, the severely damaging, which is good news because it means most of our tornadoes are survivable, right? And speaking of survivable, how many of them have actually been deadly? Of those almost 4,600 tornadoes, only, which is still a lot, but only 52 of them actually resulted in fatalities. Most of those were those high-end tornadoes, those EF3s, those EF4s, EF5s, the ones that only occur about 5% of the time. Now, that doesn't mean we can't get a fatality from an EF2 and EF1, but it's much, much more unlikely for that to happen. Yeah, if it lands right on your head, you might have a bad day. But most of the time, it's those violent tornadoes that cause fatalities, and most of the time, we don't get the big violent tornadoes. And just a little more zoomed in, you can see kind of where those tornadoes were. And they were, of course, the high end. You can see it's not a lot of the little blue dots. It's those high end tornadoes that, and unfortunately, Andover was host to one of them back in '91. So we're going to back up a little bit into the basics because we talked about how many watches occur here, how many warnings occur here, and we just want to make sure that everybody is thinking the same thing when we say watch and thinking the same thing when we say warning. Because there are people, sometimes you kind of get them crisscrossed as to which is which. And to help with that understanding, the National Weather Service thought it'd be a good idea to bring a baking example into this. And so there, to help you understand watches versus warnings, we're going to bake cupcakes. So if you wanted to bake some cupcakes, you would first gather all of your ingredients you need to bake cupcakes. And you see all the ingredients are set out. Doesn't look like a cupcake yet, does it? It's just a bunch of ingredients. And if we took half of them away, we wouldn't end up with cupcakes, would we? May end up with just a sloppy mess. At that stage, we are watching for cupcakes, but we don't have cupcakes yet. However, once we mix all the ingredients together, we have the right ingredients, we combine them correctly, we baked them, and we pulled them out of the oven, and cupcakes are occurring. Now we have a cupcake warning. Fair enough? If you look at severe weather from that perspective, a watch means we have the ingredients. We're getting the correct ingredients pulled together. It's looking like the environment will be ripe for severe thunderstorms or for tornadoes. They're not occurring yet, but we're getting the correct ingredients together, so the likelihood is increasing. So we're watching for that potential that they might occur. We're preparing to take action. We don't necessarily take action yet. But then once that severe weather develops, now it is occurring, or it is imminently occurring. We know that that storm is it's starting to blossom. So the hail's going to start falling any moment now. The wind's going to start blowing. So at that point, now you've got a warning in effect. When you look at what the warnings and watches look like, the actual products that are issued, first of all, did you know that our watches, our tornado watches, our severe thunderstorm watches are not issued by our local NWS office? Because we're covered by the Wichita Weather Service office. They do not issue our watches. They're actually issued out of Oklahoma. So the Storm Prediction Center in Norman, Oklahoma, watches, appropriately, they watch and issue watches, but they watch the entire United States, and they look at the conditions across the whole United States, and they say, where do we see things are starting to bubble and brew and look bad? And then they'll take a whole chunk of geography, and they'll slap a watch on it and go, okay, this area is the watch area. This is where we think the ingredients are coming together. And when you get a watch issued, it's for the entire county, and usually for multiple counties. But you won't have a watch that's just for Andover and Rose Hill and not the rest of the county. It's the entire county. When we get to the warning, though, now the severe weather is happening. The severe storm is there. The tornadic storm is there. And so now they're going to really narrow in and focus in on where the damaging storm is occurring. And that's the part that gets under the warning. The watch can be in effect for hours and hours and hours before anything happens, or sometimes it's a little shorter fuse than that, but it can be in effect for hours before anything happens. The warning means, okay, this storm it's right here, and we're following the storm, and the warning is around the storm and extending in the direction we think the storm is going. And color-wise, if your radar is set up appropriately or correctly, your severe thunderstorm warning should appear in yellow, and your tornado warning should appear in red. If you happen to have some fancy radar software or fancy radar app, sometimes you might see those red tornado warning polygons turn to kind of a pinkish purple. That means that is actually a verified tornado warning. So if you happen to see a radar software that all of a sudden one of them goes pink and it's pink or purple, that means somebody has observed it and they for sure know that there is a tornado on the ground. Because sometimes they'll issue the warning because they think everything's come together and they say it's radar indicated. They're looking at their radar, looking at their instrumentation and saying there has almost got to be a tornado on the ground there. Nearly sure that there's a tornado on the ground. So they might issue a tornado warning without verification, but as soon as it's verified, the warning language gets changed from radar indicated to tornado observed. So that was just a little bit of bonus info. So let's look at what actually occurred last year when it came to our hazards, our hail, our damaging winds, our tornadoes. So last year, our largest hailstone that was recorded in Butler County was over by El Dorado, and it was 2.5 inches, which would make it tennis ball sized hail. So our largest hailstone was the size of tennis balls, happened in mid to late May, and came nowhere close to our county record, which is good because our county record set back in 1959 was for a 6-inch diameter hailstone, which would kind of be like cantaloupe sized hail, I think, if you had to compare it to something. So yeah, that's not a record we want to break, but that was our largest hailstone that was reported anyway. For our most significant thunderstorm wind gust, we had a recorded wind gust in Rose Hill of 85 miles per hour, or just outside of Rose Hill, did cause a little bit of damage, some power pole damage. They couldn't find pictures of the storm while it was in Butler County when they built this presentation. So the pictures are actually from Derby, just to the west of reaching us. But you can see a very substantial storm cloud, and you see some of their power poles bent over. This also did not break any records, because our records currently stand at 100 miles per hour. 3 different storms created 100-mile-per-hour wind gusts. In 2007, actually here in Andover, there was a 100-mile-per-hour wind gust. 2008, Douglas hosted a 100-mile-per-hour wind gust. Neither of those had any reported injuries, but definitely had some property damage. And then also in 2008, northern Butler County had another 100-mile-per-hour wind gust. This one, unfortunately, did cause an injury. It also killed some livestock in addition to property damage. So, yep, didn't break any records there either. Now, this one might be a little surprising. I said we had no tornado warnings in Butler County last year, but we got credit for a tornado in Butler County last year. So why the disconnect there? Well, the tornado that was reported, you see it's one of those EFUs, sorry, get my right EF here. It was one of those EF unknowns, and it was recorded just outside the El Dorado Lake. This was actually a landspout tornado, and we're going to talk about what makes a landspout a little later on. And you can see in the picture just a little bit of a fingerling of a tornado there. This is the message that we got from the National Weather Service as this tornado was identified and as they were talking about the environment. And they basically said, we have an area that is supportive of weak, brief landspout tornadoes. And by the way, there was one, and here's where it was at, and more of them could occur. But they were not concerned because this was not an environment where we were going to create anything larger, any big damaging tornadoes. Like, yeah, just these little guys. Don't worry about it. Not a problem. So that's why we didn't have a warning in coordination with that little guy. So yeah, we did have a tornado. Fortunately for the Andover people, you guys still hold the record for the largest tornado in Butler County, the 1991 tornado, which unfortunately also still holds the record of being the second deadliest tornado in Kansas. Does anybody know what the first deadliest one was? Yeah, Udall still holds that record. But this was the second deadliest. A lot of injuries, a lot of fatalities, a lot of property damage. So again, this is not a record that we want to break. And let's not try again. I know in 2022, you guys tried to host a second tornado, but let's not do that again. There are a few pictures of that tornado. So that was the famous video that was taken from Teradyne Golf Course, as well as some damage pictures. So that thing was a monster, definitely. But we do have one other tornado that is given honorable mention, not quite as large as that one. But in 1958, there was what they are calling an F4 tornado. So the Andover 91 was an F5. They're calling that one an F4 that went through El Dorado. The reason I say they're calling it that is back in the 1950s, they didn't have the Fujita scale yet. They didn't have a way to measure or to rank tornadoes. So they actually did after the fact. Once the scale went into effect, they looked back at historical data and they tried to, after the fact, or back rate a lot of historical tornadoes. So looking at the damage, kind of in the rearview mirror, sort of, they said this was probably an F4 tornado. It is the 5th deadliest tornado in Kansas history. It is also, at the time, it was referred to as the wrong way tornado because at that time, they thought tornadoes are supposed to start in the southwest and go to the northeast. That's what tornadoes do. This one had the nerve to start in the northwest and go to the southeast. So like, oh my gosh, it's going the wrong way. Well, now that we've seen a lot of tornado data and there's been a lot of recorded tornado tracks, we realize that tornadoes go wherever they want to go. They may stand still. They may some have actually gone in a circle. They go this way. They go that way. There's no telling a tornado what to do. It is wrong in another way, though, too, in that in the national database, the track got recorded in the wrong place. So if you look up the national records, it says that the tornado went north of town. But if you look at all the damage records, it was at the south end of town. So yeah, that's wrong, too. Here's some of the pictures from that tornado. The tornado damage. Have any of you seen the special that Cake News did like a year or so ago? Frank Waugh put together. It was called The Dawn of Doppler. That sound familiar? So he did a special on the originations of actually using Doppler radar to record and track tornadoes. That El Dorado tornado was actually the first Doppler recorded tornado. So he spent a lot of time researching that El Dorado tornado. And during that process, he did a lot of talking to like historical societies and also Butler College. And Butler College is like, hey, by the way, we actually have video footage of that tornado. So that is actually that 1958 El Dorado tornado. So if you're interested, you can go look for that Donna Doppler program. It's about, I think, about 30 minutes long. It's pretty cool. All right, so that was our history. Looking at history, looking at recent history, past history, records, that kind of thing. Let's look at how you actually put together a thunderstorm, though, because there's a lot of information. There are a lot of clues inside a thunderstorm that tell you if they're strong, if they're weak, if they're moving towards you, if they're moving away from you, if they're going to develop massive hail, or if they're going to just fall apart, or if they're going to produce a tornado, which is something we're very interested in. So there are actually several types of tornadoes, but, sorry, not tornadoes, those two, but thunderstorms. There are several types of thunderstorms, but all of them pretty much follow the same life cycle. You'll have the storm will start to build, will start to grow, the ingredients start to come together, and then it'll grow and it'll reach a mature stage. And at the mature stage, that's when it's doing the most damage, when its hail is the biggest, the wind is the strongest, the tornadoes are most likely, if it is a tornado producing storm. And then it hits the dissipating stage and it starts to die and collapse in on itself and still can cause some problems. It's not completely harmless at that stage, but it's, gradually just dissipates. And most of the time, the average works out that most of the time, that whole cycle takes about 30 minutes to complete. Now, we have storms that last way longer than that, but the average calculates out to about 30 minutes. But no matter what type of storm we're looking at, because there are multiples, but no matter what type of storm we're looking at, every storm has to feed. It has to have somewhere where it's ingesting storm fuel. And the ingredients that a storm loves to eat is warm, moist air. So somewhere the storm is gobbling in warm, moist air. And when you can find the place where it's feeding, which is also called the updraft, that is, first of all, one good place to look for information on how powerful the storm is. It also, the updraft tends to be the area where most of the problems can happen, some of the biggest issues, the most damaging winds, the most tornado potential. So we always want to try to isolate, first of all, where is that updraft? This example happens to be a supercell thunderstorm, and in this case, the updraft is a tower, but that's not the only way that an updraft can form. But in this sort of storm, it's actually a tower, or this billowing column that goes up into the sky, potentially 50,000 feet into the atmosphere or more. But as we're looking for the updraft, once we isolate where it's at, we kind of want to look at its structure. Does it look very weak and wispy, or does it look really chunky and crisp and robust? So the guy over there on the left-hand side looks a little bit like cotton candy on a stick. It's just wispy, it's very soft looking, kind of looks like you could pull it apart. But the one on the right and at the bottom looks very put together. It's like heads of cauliflower all jammed together, or balls of popcorn all just mashed together. Much thicker, much more robust. So that's a severe and a disturbing storm on that side. On the other side, it's a weak, maybe it can produce a little wind and hail, but not as concerning. And that just gives you another view of a very weak one versus an updraft or a feeding area of the storm that's very strong. So as a little aside, there are several tools that meteorologists use to gather information about where the storms are, what they're doing, how they're growing and progressing. And those tools, a lot of them are available to us as well. One of the things they look at is satellite imagery. They actually can see where the clouds are billowing up. And there's sites out there where you can go and look at satellite imagery. But what's more useful to us is having access to some radar information as well. How many of you actually keep radar on your phone or on a desktop computer or on a laptop, or have some kind of radar you reference? Okay. Well, the nuts and bolts are the basics of how the radar works. So that picture up there, that's actually the National Weather Service office in Wichita. And what looks like a great big golf ball there, That's the radome. And inside of that dome, there's a dish that's just spinning and spinning and spinning. And it's shooting out beams, just throwing them out into the world. And it's waiting to see if that beam will hit, those beams will hit something and bounce back to the radar site or reflect back, which is why that view that we have of the radar down there is called reflectivity, because we're reflecting beams back. So as those radar beams go out into the atmosphere and they hit something and they bounce back, the more beams that get reflected back, the more stuff must be out there. And usually that stuff, when it appears on a radar view like that, is something to do with the storm. It's rain, it's hail. The more of it that's out there, or the bigger it is, the brighter the colors get, the more concentrated. Now, you can have other things bounce back a radar beam. You can have flocks of birds. You can have dust, billowing dust like in a dust storm. You can have grass fire smoke that'll reflect it as well. That view down there, that's definitely a storm. So that tells us something about where the storm is, and then again, how concentrated the rain and hail is, how much. But there is another view as well. If you're dealing with a radar app or playing with some radar software, you should hopefully have a view of not just reflectivity, but velocity as well. And if you flip to the velocity, the colors change, things look a little different. But what this view tells you now, instead of just, we're throwing these beams out and they're bouncing back and we're saying, how much stuff did you bounce off of? Now the question that the radar is asking is, okay, I threw out some beams, I bounced off this stuff. How fast was that stuff moving? And that's how we get some wind speed information. And on those views, if you see red, it means whatever that stuff is moving away from the radar. Green, it's moving toward the radar site. And the brighter they are, the faster the wind speeds are. So what do you suppose it means if you look at a velocity view and you have this really concentrated knot of bright red next to a really concentrated knot of bright green, and they're right beside each other, which means it's going away from the radar site and toward the radar site at the same time, or right next to each other. Exactly. It means something is spinning there. Now, it does not necessarily mean it's a tornado. It could be a tornado. Could be the whole storm is rotating, which is something that's possible. But it's definitely an area you want to pay attention to, and maybe pay attention to it from a distance, not like get under it and look up to verify. All right, so let's talk about what those actual types of thunderstorms are. So on the very least severe end, we have what are called single cell or pulse thunderstorms. These are the guys that they bubble up, they maybe drop a little rain and hail, maybe a little wind, and then they collapse down. Really, really short-lived. These are probably the most common, which is also why we have an average thunderstorm life of 30 minutes, because we get a lot of those, so they skew the numbers. A lot of short-lived little pop-up storms. These are like your July thunderstorms that they pop up, they rumble a little bit, and then they're gone. They don't really live long enough or get structured enough to do really large hail, really significant wind. They don't, they're not the big tornado producers, anything like that. They're just whoop, there and they're gone. Now, if you get several of these guys together, you get a cluster of them, they can get themselves a little more amped up. Maybe the hail size gets a little bigger, the wind speeds get a little more substantial. What we worry about with these guys is if we get a bunch of them that are brewing up and moving over the same space over and over again. So the first one comes across Andover, and the second one develops and comes across, and the third one comes across, and the fourth one comes across, and they're each dumping heavy rainfall. What do you suppose happens then? Then you get flooding issues. Yep, streets running with water. So that's what we worry about with those guys, is what they call training thunderstorms, where they just train over the same area over and over. Then you get to the severe end, and these two we're going to spend more time on. We have first the squall line and then the supercell, and those are your severe thunderstorms. These are the ones that we're looking out for. So let's start with the squall line. So the squall line is a little more simplistic, because really what he is he's just a long line of a storm, just a really long line. If one formed today and we looked out, say toward Wichita, you'd basically see a line that went horizon to horizon, a big long storm just rolling toward you. And if you looked at it on radar, maybe it stretched the length of Butler County, maybe it stretches from Texas all the way to Ohio. And if we look at him On radar, you see just a really long line, and can be rather skinny too. Just that line moves through and then you're done. Now these guys are definitely longer lived than those 30-minute pop-up thunderstorms. So they're longer lived. They also, because these are the ones we're worried about because they're more severe, their big thing that they're capable of doing, or their big specialty, is creating damaging wind gusts. So this is the thing that they're most into doing. They can produce larger hail, so you can get quarter size, golf ball size hail. They can produce tornadoes. Sometimes they will produce a spin up. If they do, most likely where those are going to occur is on the front end of that storm or the leading edge of the storm. These, though, are not the storms that are going to produce those great big EF4, EF5 tornadoes. That's not what they're built for. That's not what they specialize in. But damaging winds, that is what these guys are most known for. And they can create damaging winds that go for hundreds of miles. That storm can travel clear across the United States, just blowing wind and blowing wind and blowing wind. And there's a couple of different terms for these storms as they get really ramped up and really nasty. So the derecho, if you've ever heard of that one, that's that really long-lived, extremely damaging, it's marching across the entire United States storm. And then you have another version of it that looks like up there. So I said these are a long line of a storm, right? But those don't look very straight line, do they? You notice how they're actually curving outward? These storms can start to bow out and create what's called a bow echo. And if you see where those arrows are pointing on the radar image up there, what's happening is you had a nice straight storm, long line of a storm, and then somewhere behind the storm, this wind starts diving out of the upper levels of the atmosphere, and it starts punching the storm right where that arrow is. It just finds a spot, it just starts punching it and driving it forward, and that one section of the storm starts moving faster and faster and faster, and that's what causes it to bow out like that, which also means the wind coming out of the storm is going faster and faster at the point of the bow. So that's where the most damaging winds are. And they can get 80, 90, 100 miles per hour at the point of the bow. In fact, last summer, the Wichita airport, they had a bow echo squall line that went over top of Wichita, and they recorded a 102 mile per hour wind gust, thunderstorm wind gust, from the bow echo portion of a squall line. So yeah, we don't like those. So as you're looking at the squall line storm coming toward you, does anybody recognize that structure, or what that cloud is, what it's called or what it's known as? Anybody remember? I heard somebody say shelf, I think. Yeah, so that's the shelf cloud. Remember I said this thing is horizon to horizon? You're going to see this long strip or this long shelf just advancing toward you, probably as far as the eye can see. And in this case, you're dealing with a severe storm. So that's a very robust shelf cloud. It almost looks like there's a whole ribbon of bacon running along the top of it, and then a scruffy little skirt underneath it. It's got a lot of depth, it's got a lot of structure. It's not just a scraggly little line of pop or cotton candy clouds. What this is, what you're actually looking at when you look at the shelf cloud, this is that updraft. This is the feeding area of the storm. This is where it's gobbling in its fuel to build itself up. The way that it does that is really, if you think of it, picture a squall line storm as almost like a huge snowplow blade. So it's trundling along across the landscape, and it's just pushing all of this cold downdraft wind out of the storm. So it's almost like a big blade that's scooping down underneath all the warm, moist air ahead of it, because remember, the storms love warm, moist air. And as it scoops down under that warm, moist air, that all just kind of gets plowed up into the storm. That creates that shelf cloud look as all that warm, moist air is just plowed up the front of the storm. And so that is where the storm is feeding. And remember I said if you find the updraft, that's the more dangerous part of the storm too. When you see that shelf cloud coming towards you, be thinking strong straight line winds. This thing is probably going to, in fact, it's probably going to blow you over before the storm even rolls over top of you. So here's some very nice robust shelf clouds. You see the ribbons of bacon, the nice scruffy little skirts. And then here and kind of sped up, you can see that shelf cloud rolling towards you. There's a scruffy little skirt. And you notice it's dry, 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 dry. And then now the rain is falling. So you get that big blast of wind, you get that shelf cloud rolling over top of you, then you start to get all the moisture behind that. And if you look at him on radar, this is a squall line under development. You notice that he started out as a bunch of little spotty storms, and then eventually they were all kind of traveling in the same direction. They just start kind of filling in and merging together and forming one big long line. And then now you have a squall line. And that's about all there is to those. They're pretty simple. Any questions about squall lines? So far, so good, right? All right, so now let's talk about the granddaddies. So the big monstrosities, the supercell thunderstorms, these are the ones we are especially concerned about this time of year, because in the spring, and this is when we have the prime environment to create a supercell. These guys, unlike the squall line, that where the updraft is up at the front and it's a big old shelf and we're scooping warm air up the front of it, these guys, they're going to be built in a very different way than your squall line. Now, they are also long-lived storms like your squall line, but these guys, they do it all, and they do it big. So they have the potential to create extremely large hail. You hear Reed Timmer screaming about gorilla hail and stuff, and yeah, really big hail can come out of these storms. You can get extremely damaging winds out of these storms. And this is the type of storm you need. If you are going to create one of those great big monstrous EF4, EF5 tornadoes, you got to have a supercell. And even worse is if you have a whole bunch of supercells developing on the same day. Now, sometimes you can have a bunch of storms pop up, but then they start fighting each other like kids in the playground. They all want the fuel, they all want the ball, and eventually one will suck all the energy in and the other one will die. But if you can get a bunch of supercells that are all behaving, like keeping separate from each other, they're finding their own fuel, they're not fighting, and they stay, what meteorologists will say is they stay discrete or separate. Those are the situations where you can also have not only tornadoes, but tornado outbreaks, because each one is a potential tornado producing monstrosity. So, and speaking of tornadoes, let's go back to, real quick, before we talk about the supercell components, let's talk about that EF scale. So tornadoes that occurred from 2007 and forward are all rated on the enhanced Fujita scale. So they have an EF rating. If they were prior to 2007, that was the original Fujita scale. So if you see historical tornadoes like the El Dorado or the Andover one, it says it's an F4 or an F5. But then we're like, oh, but the one in 2022 was an EF3. That was because just a change in the scale. An EF rating or an F rating from the old days is not assigned until after the storm is over and after meteorologists have had a chance to assess the data. We cannot actually assign an EF rating during the tornado because unlike what you see in the movies, we can't stick something in the tornado and see how fast it's spinning. We have to wait till it's over and done. And then once the storm is over and the tornado's done and everything's cleared, what they'll do for their damage assessment is they'll go out and they'll look at the damage that was done. They'll look at the power poles that were snapped, the trees that were uprooted, the roofs that were cleared off, and they'll look at the damage very, very, very closely and say, okay, what wind speed would it take to snap the power pole that way, or to peel off the roof that way, or to completely wipe the house off the foundation? And then they estimate, well, to do that damage would be about 110 miles an hour. Okay, high-end EF1. To do that damage, okay, that would take about 140 miles per hour. Okay, so that is a lower-end EF3, and that's how they go about assigning that EF scale, is after the fact, looking at the damage and trying to back into what the wind speed was. What's kind of interesting about the one that's, you see the picture in the background of that tornado, and over top of it, it says, EF5 tornado, Enderlin, North Dakota. That was last summer, June 20th. First weird thing is there was an EF5 tornado in North Dakota. Not exactly where you'd expect it to occur. The other thing is that was an extremely notable tornado for one very specific reason. Initially, it was rated as an EF4. Then they went back and re-looked at the damage and upgraded it and said, oh, you know what, that was an EF5. Anyone know what was significant about that EF5? That tornado last year broke a 12-year drought. We had not had an EF5 in the United States since the Moore tornado in 2013. Yeah, 2013. We had a 12-year drought. That is the good kind of drought to have. We don't like real droughts, but that was a good drought to have. So we finally broke that drought, and that was the first EF5 in just ages. Now, when you're looking at tornadoes, especially when we get to the part about reporting tornadoes, we want to be very descriptive about how we explain what we're looking at. I know adrenaline can make any tornado look like that's a really big tornado, but we like to use more precise terms. So this tornado, he looks like a rope hanging out of the sky, so he's called a rope tornado. And then you look at this one, nice and thicker at the top, narrower at the bottom. This is actually what the 2022 tornado looked like. Nice cone tornado. Now, sometimes they call them elephant trunk tornadoes. Sometimes if they're that wide, but it's kind of the same top to bottom, they might be called stovepipe tornadoes. But then, of course, the really big monstrous looking ones, those are your wedge tornadoes. The thing I want to caution you about is, remember we said we cannot rate a tornado until after the fact? That also means you can't just glance at it and go, oh yeah, that's an EF5. The problem is that it all depends on the wind speed inside the tornado. And you can have a cone that's gotten itself really, really, really ramped up, and that thing's going at like 180 miles per hour inside. And you can have a wedge that's just really lazily doing about 160 miles per hour. And so just looking at what they look like doesn't really tell you what their rating is. So yeah, don't make that mistake and think just because it's skinny, it's not dangerous. And just for a little effect, there is a wedge tornado. Anybody see what the date is on that? Oh, you actually saw that one? Or you were taking cover, right? Good. What else happened on April 26, 1991? Yeah, that was the same night as the Andover tornado. Apparently there were other tornadoes going on too. I promised you we'd come back to talking about what the land spout is and why the land spouts don't get meteorologists excited and why we didn't get a warning out of that one. So most of your tornadoes, when they form, you've got this big old supercell storm and something's happening up here and things are spinning and environment's coming together, and then your funnel starts to descend and then the thing contacts the ground, and it's pretty much a from the storm down type of situation. And that is usually, not always, but usually much more visible on radar too, is the meteorologists can see that stuff starting to happen, see that rotation occurring, see that storm ramping itself up. Now, land spouts actually can occur when you just have a garden variety thunderstorm, not a supercell thunderstorm. And what's happening with these is, and they've been referred to as like glorified dust devils or dust nados, but what's happening is somewhere because of just this conditions, the environment, a little bit of spin has started happening down at the ground. And you've seen the little dust devils that'll all of a sudden whirl themselves up on the ground. So a little spin's going on. And along comes this thunderstorm. And it's sucking stuff up. It's taking that warm, moist fuel up, and it's ingesting. You got this updraft of fuel going up into the storm. And that updraft happens to cross over that little bit of spin. And it sucks that little bit of spin up into it. And so all of a sudden, you get a land spout that's connected up to the storm. It's not in a traditionally big monstrous supercell. It's not formed in a traditional way, and it's probably not going to get a whole lot bigger than that. If it goes directly over you, yeah, it probably still cause a little bit of damage. But because this isn't the environment for big, monstrous, damaging storms, that's why meteorologists are like, yeah, it's a land spout. Yeah, don't get excited. It also means because they form differently, it's really hard for them to predict it. They can kind of tell if the environment, like that message I showed you earlier on, they can tell, hey, this environment seems to be the kind that could produce some land spouts. So they might put some messaging out just saying, don't be surprised if you see a land spout. But they're not blowing all the horns and issuing tornado warnings. So if you were going to build a thunderstorm, a supercell thunderstorm, just like you're baking your cupcakes, which of these do you think are the ingredients you would need to make that supercell? Do you need wind shear? Do you need moisture and instability? Do you need lifting mechanism? Do you need a guy behind the curtain that's pushing the big supercell button? What do you think? That's definitely part of it. Do you need anything else? All of them? Yeah, all of them except for D, right? Yes, all of the above. There is no big magic button. Meteorologists cannot create thunderstorms, cannot create hurricanes, none of that fun stuff. But it does. It needs wind shear, which we'll talk more about in a second. Moisture, remember I said warm, moist fuel, warm, moist air, that's its fuel. Instability just means that the temperature of that warm, moist air going up is different than the atmosphere around it. So as long as that updraft, that fuel going up, updraft, stays warmer than the air around it, it'll just keep rising. And that's what instability is, essentially. And a lifting mechanism is just a spark. We need something to light those ingredients and light them off, like a dry line, like a front going through. So what is wind shear? Wind shear is a vital ingredient for supercells. It basically means that the wind speed down here at the bottom or at the ground is substantially different than the wind speed way up in the environment, upper levels of the environment, atmosphere, whatever that word is I'm trying to say. This is an example of poor wind shear. And this is an example of not a good environment for supercell thunderstorms. So in this example, it's 10 miles per hour wind speeds down here, and it barely changes all the way up to the top of the environment, all the way up to like 20,000 feet or 30,000 feet. In this case, you can still build a thunderstorm. So your warm, moist air, you can have the ingredients like the moisture, you can have the instability, you can have other ingredients that cause that updraft to grow. The tower starts to go up, the thunderstorm starts to form, but it just grows straight up in the air. And as it grows straight up in the air, and all that fuel it's feeding on is going straight up, stuff has to come down too. Thunderstorms have stuff that comes out. You have wind, you have rain, you have hail, and all that stuff is cold. And so you got cold going down on top of your warm fuel that's coming up, and pretty soon the two colliding with each other cause a short circuit and the storm collapses. So these guys in that kind of environment are not going to last long. That's kind of like what you get in July when you pop up and they're gone, pop up and they're gone. However, in the spring, when you look at our environment, especially during our storm season months, is you can have a lot of days where you have a substantial difference. 30 miles per hour wind speeds down here, 110 at the top of the atmosphere. And in that case, as that tower is building and that updraft column and all that fuel is going up the updraft, it's getting pushed at different speeds along the whole length of the tower, and those really strong wind speeds higher up start to tilt your updraft over. So now that big feeding column, that core of the storm, is at an angle. And when that happens, now when stuff comes out, your rain and your hail and your wind, they're not doing it where the storm is feeding. They're doing it out ahead of the updraft. And so now you feed, you drop rain and hail. You feed, you drop rain and hail. And you create this cycle and this circuit that just continues and continues. The storm lives longer. The longer it lives, the bigger it gets. That also means the more severe it can get. And if you want to really put the icing on the cake and have a super severe thunderstorm, what you need to do is not only get that updraft column to tilt, you want to get that whole thing to rotate. And the way you do that is when you have winds that change not just speed going up, but they change direction going up as well. So you're hitting that updraft at different directions all the way up. And the next thing you know, that whole column starts to rotate. So the entire core of the storm is spinning. So let's say that we stepped out of class this evening and the sun was still up and you looked in the horizon and that is what you saw in the distance. Would that concern you at all? Huh? So that is a supercell thunderstorm. And there are some clues as to what that storm is capable of just from this view alone. So we got 3 features we're going to look at. First being, we got our updraft. That's the core of the storm. That's that tower, that column where that storm is feeding. Does it look wispy or does it look chunky? It's chunky, isn't it? So yeah, that's a very strong updraft. Now, this updraft column is not going to rise forever. Eventually, it tops out because it just can't go any further. Things not going to go clear off into space. So it hits a level where it can't go any further, but now it's got to do something. So once it hits that upper level of the atmosphere, the column, it's already tilted, but now it's just going to kind of tilt. And as that happens, and you've got the winds, remember, up there that are pushing that storm along, it takes the top of that updraft and it just pushes it forward. That creates that lid on top of it. And if you look at the storm, this angle is not a good angle of it, but if you look at the storm, usually you'll see that that updraft will that anvil will stretch much further out than just the width of the storm. You can think of that anvil basically like a finger. It tips over, gets pushed the way the storm is going. So if you look at it and think that's a finger pointing the direction the storm is going, right away you can say, oh, that storm is going away from me, or it's coming toward me. The thickness of the anvil also tells you a lot about the storm's strength. So if it's also thick and chunky and robust like your updraft, like that one, another sign the storm's severe. And then we have this weird little thing on the top, and they call it an overshooting top. And what it is we've got something that didn't get stopped at the upper level of the atmosphere. Most of the storm topped out, created that nice lid, that anvil, but then something in the updraft punched through and is actually rising above the anvil. That again is just a really big red flag that you have a powerful storm, really strong updraft, and a lot of severe potential. Well, those were the features you could see from a distance. And they basically give you a little bit of information about which way is the storm going and how severe it is. What we really want to know is what is the storm producing? And especially we want to know, is this guy capable of or already producing a tornado? And that kind of information we get by peeking under the storm skirts. So now we're going to look at the underside of the storm, which is visible a whole lot closer. Now this is where, if you look at where it says inflow, that is where that warm, moist air is going into the base of the tower. So our storm is actually tilting up toward that radar image. Not sure, I don't have a pointer on this, but it's the updraft column is kind of going up to the upper right corner, and the inflow is all the warm, moist air that's flowing into it. And then you have that other thing. Did it actually do its blue thing? Come on, do your blue thing. Yeah, there we go. Over there, do you see where it's kind of gray? So remember what I said, as soon as it tilts, we get that separation between where stuff's coming out and stuff is going in. So we've got the warm, moist air that's flowing in, feeding the storm, and then out ahead of it, all that rain and that hail and that wind is coming down out of the storm. So that's where that gray area is. It falls out ahead of the storm, so that also tells you that's the front of the storm, or it's going in the direction of that rain and hail. They call it a forward flank downdraft because it's forward. It's at the front of the storm, and it's got stuff coming down, so that's the downdraft. Just a fancy name for this is where the stuff came out. And then under the base of the updraft itself, you notice it's clear. There's no rain, nice visibility, because all that rain and hail and stuff's falling out ahead. So when you find that clearing section under the storm, that is probably the base of your updraft. Remember I said the updraft is our problem child. That's where we look for issues. It has, hanging under this one, this low hanging something dangling from underneath the storm. That's concerning. How many of you have heard of a wall cloud before? Yeah. This is one of the signals that we're looking for as to whether or not this storm is capable of producing a tornado. I would love to be able to tell you that nature is very, very, very methodical. And the first thing we do is we create this tilted, rotating updraft storm, and then we get a little lowering called a wall cloud, and then we get a little funnel cloud, and then the funnel cloud touches the ground, and now we have a full-fledged tornado. It doesn't always happen that way. You can get a wall cloud that appears that never becomes a tornado. You can get a tornado that drops that never had a wall cloud. But a wall cloud is definitely a signal that we could have an issue. We could be progressing toward a tornado. But what we want to know is that wall cloud, first of all, is it really a wall cloud? And is it staying? Did it just kind of peak out and it disappeared? Or did it lower and stayed? And we want to know, is it rotating? But remember, I said that the entire storm could rotate too. So we want to make sure that we're looking specifically for wall cloud rotation, not just storm rotation. If you find your updraft and the whole thing looks striped like a barber pole, or it looks like somebody just took fingers and raked them along through some frosting on a cake, those stripy little things, those striations, that shows that the entire updraft is rotating. What we want to do is look closely at the wall cloud itself and see if the wall cloud itself is also rotating on its own. Best way to tell if it is to pick a spot on the wall cloud and then just follow that spot. If it stays still, it's not rotating. Now, if you pick a spot on that cloud or that wall cloud, you could definitely see it progressed across the screen. Got another one. Again, you just pick a spot, one of the fringes, and you can see it actually traveling. That is a rotating wall cloud. A non-rotating one, this is actually a video, but nothing's happening. You pick a spot, like the little dangly off at the far end of it, the right side of it, it just stays there. Nothing is moving. So not a rotating wall cloud, so not quite as concerning. We may want to watch it, see if it eventually develops rotation, but it's not nearly as concerning as the one that has a spin on it. So let's do a quick test. Is this, whoops, I just gave you the answer. Okay, so that was your sample of what this is going to look like. Is the thing under there a wall cloud? Yes, it is. Okay, so that was your example. Let's try this one. Is this a wall cloud or a shelf cloud? Shelf cloud? So yeah, so that time we're dealing with a squall line thunderstorm, and it's a shelf cloud. Okay, got some crud hanging out from under that one. Is that a wall cloud or a shelf cloud? It is actually, that portion right there is a wall cloud. This guy. Big old shelf cloud. And that is definitely a huge squall line thunderstorm. Come on, go. This one's a little bit more difficult because your eyes might be drawn way to the back of it and you think, oh, there's something hanging down there. But if you take the whole entire picture into perspective, what do you think you've got? Yeah, it's actually because of your angle, it's already largely past you. That whole U-shaped thing is your shelf cloud, and the stuff down at the end is just dust. What about this guy? He's just looking like a big old mess. Do you see anything? It is actually a wall cloud, but it has a tail cloud attached to it. Sometimes the area where all that inflow air is going up and into the base, it starts to actually condense and form a little cloud. So that's air, or that warm, moist air that's feeding into the storm. And if you see that kind of thing and it's pointed toward your rain and hail, it's probably a tail cloud. So yeah, that was kind of a trick. All right. Your turn, Wayne. All right. Not a wall cloud, not a shelf cloud. It is an SLC, or a scary looking cloud. So the scary looking cloud, what makes it different from a wall cloud is a scary looking cloud is essentially something that scares everybody because it's dangling underneath a big storm. You're like, oh my gosh, it's got to be a funnel. It's got to be a tornado. It's got to be something bad. But it's just ragged bits of moisture, or bits of cloud hanging out under the storm. One of the big ways to tell if you're dealing with a scud cloud, an SLC, or a wall cloud is that your wall cloud has to be firmly attached to the base of your storm. If you see any daylight between that storm base and the stuff that's hanging out down there, not a wall cloud. So yeah, we're looking for the stuff that's very attached, it's hanging out, we're looking for rotation. But then we got this other little wrinkle in the whole system, and that is your microburst, your downbursts. These guys If it happens around you, you may swear up and down that you had a tornado because you might have heard a roaring sound, and then all of a sudden this boom of something happens, and you come out of your house and your chicken coop is absolutely obliterated. It's in pieces in every single direction. Well, it may actually be this guy, which is a microburst, which for whatever reason, the storm just decided as it came over top of you that all of a sudden it's just going to dump wind and rain, just boom, right down on top of you. And it's straight line winds, but instead of going this way, it's going straight down at you. And if you happen to be at the point where the microburst first lands, yeah, it causes a lot of damage. This just shows a time lapse of one sped up. See, it just all of a sudden just decides to throw a bunch of stuff out of it. Think of it like a supercell tantrum or. Okay, so real quick, the difference between straight line winds and tornadic winds. A straight line wind is coming out of the storm and going away from the storm itself. And usually straight line winds will cause debris to all get pushed in one direction. Where a tornado, it's doing a couple different things. You do have the tornado itself. So you got that thing that's spinning along, and if it runs into your house, it's going to chew the whole thing up, and the body of the tornado itself will make a mess too. It also, though, it's sucking in a bunch of inflow winds into the tornado and pulling that all into its spin. Have you guys seen the drone footage from the 2022 tornado that Reed Timmer took as it was going past Prairie Creek Elementary? Has anybody seen that? If you watch that, you'll see the tornado's over here. Prairie Creek's in the background. The tornado is over here on your right-hand side. And as it's going along, you can see it's definitely impacting the houses it crosses over. But if you look real closely, you'll realize that pieces of houses and roofs are actually getting sucked up into the tornado long before the tornado actually gets to that portion of the neighborhood. Because it's just sucking stuff up into it. Let's do a quick test. See if you can tell the damage. Looking at this picture, do you think this was caused by straight line winds or tornado winds? Does it look like straight? Like everything's going all in one direction? Yep, everything got pushed to the back of that picture. How about this one? Yeah, if you really got down in the weeds on this one and looked at which way the debris was thrown, it's been tossed every which way. Very chaotic. How about that one? Tornado or straight line? Yeah, this one is actually tornado as well. Sometimes it's hard to tell without getting down into it. But yeah, some of the debris is going down toward the bottom of the screen. Some of it is going off to the left. Some of it is going up toward that field. How about that guy? Straight line? Yep, everything's going all in one direction. And how about this one? Yard sale? Or no. Yeah, that's all straight line winds. It all pushed in one direction. All right, so this is about a little over the halfway point. So I like to give you guys about a 5-minute break to just stretch your legs, use the restroom real quick. If you didn't get one of the preparedness information stuff from our volunteers at the back, you can visit them. Got a couple of folks from the Flint Hills Amateur Radio Club that are here to talk ham radio. So give it about 5 minutes. Please don't run away. Please come back. And then we'll continue on. science under our belts, now that we've got the whole how to identify if a storm is getting amped up, if a storm is capable of producing hazards, let's talk about what you do if you actually get tangled up with one of these storms. So we're going to do a few situational examples of people out on the road and what it looks like, and kind of talk about what some options are when it's you versus Mother Nature. So first of all, if you are planning to intentionally go out and watch the storms and observe the storms and report on the storms, you're one of them, huh? Raise your hand. There are good places to position yourself, and there are not so good places to position yourself. This little kind of cartoon version of a storm is a little bit harder to make out the details on, so I'm going to overlay a radar image over top of it. When you actually are looking at a radar, you can actually see the parts of the thunderstorm that we have talked about. A lot of them are visible actually on radar in that picture right now. So this is a classic supercell thunderstorm. Remember when I said the anvil is going to sprawl out, and it's going to sprawl actually ahead of the body of the storm? Well, all that sprawl that you see on the right side of that radar image, that's all where your anvil's at. So that's why it's so much wider there and it's so much narrower at the back end, because all that sprawl is where your anvil's at. So right away we know if the anvil is the finger that points where the storm is going, that sprawl area, that anvil is saying that storm is going up to the upper right corner of the picture. As you get further back, you see how the colors get a lot tighter and more concentrated and brighter. And that means that more beams are being bounced back to the radar site. So there's more stuff out there that they're bouncing off of, which means that's probably where your concentration of rain and hail and just all that stuff that's coming out of the storm is, because that's all bouncing back radars. So, okay, so that gives us remember our gray area, our downdraft, forward flank downdraft. All right, so that's where all that's happening. And then you step behind that, and you see that it's a lot more clear. There's a lot less stuff going on and reflecting back the radar image. That area, which is where that X is located on the drawn map, that is that rain-free base, or that base of that updraft tower, the base of where that storm is feeding. And what happens in that area of the storm, if you're looking at a supercell thunderstorm? That's where your tornadoes can form, correct? Yeah, so and you see a little bit more, it seems like the radar image kind of hooks around behind that blank area or that clear area. That is that hook, they call it a hook echo. That's appearing because that entire updraft column is spinning. So a little bit of stuff's getting pulled around it, and you just get kind of that image of a hook because you've got a rotating supercell there. So come back, we got to get back to here. So when you're looking at where you want to position yourself, obviously up at the front of the storm, if you position yourself there, you're right in the path. It's coming straight at you, correct? If you go where the X is, it's all dropping on you. If there's going to be a tornado, it's dropping on your head. If you go up to the top in that gray area, yeah, you're going to be safe in that the storm is moving away from you. But if you're up there and you're trying to observe if there's a tornado, you're looking right through that concentrated area of rain and hail, and you're not going to see anything. Conversely, if you're on the very back end in kind of that tan area, again, the storm is moving away from you. So from a safety perspective, not a bad option. But two problems here. First of all, sometimes the storms will actually just dump some just really strong straight line winds off the back end of them as well, just because they like to get you. And if you're standing at the back end of the storm, you can get pummeled by some of those. They call them RFD winds, or rear flank downdraft winds, and just bam, they get you. The other problem is that by standing there and looking at the storm going away from you, that means that all the rain and hail is ahead of you, so that's going away from you. But that creates a backdrop that's basically just a big gray curtain. And if a tornado drops, and that's probably gray too, you're really not going to see a whole lot. You're going to see gray on gray. However, if you're where that car is at, and the storms, the rain and hail is the gray downdraft area is to your right, and your rain-free base is like in front of you or a little bit to your left, what you see is like that picture up there at the top. If a tornado drops, you got clear skies behind it. So you have perfect visibility to that thing coming down. So that is your ideal from a spotter perspective. Not to mention the fact you also have a lot of outs because the storm is going that way and you can go the opposite way. So let's say this is you. You're out on a country drive and you look ahead of you and you see this. First of all, what kind of storm are you dealing with? It's a shelf cloud, which means it's what kind of storm? The squall line? Squall line, long line of a storm, horizon to horizon. And you pull up your radar and you're like, yeah, we have a long line of storm, but is it a straight line? No, that thing's starting to bow, isn't it? And where are you? If you're the blue dot in relation to the bow, you're right at the bow. Yeah, it's coming straight at you. So you're looking at your map, and let's zoom in a little bit. And let's say that you are, so K96 is up there. Highway 14, let's say you're on Highway 14, and Haven is off there. You're off toward Hutchinson area. And you're like, okay, that storm is coming right at me. Do we want to just stay put and let it roll over you? If you're at the bow portion of the storm, maybe not. If the storm is stretching from Texas to Ohio, is there an end you can go around? Not really. But it is preferable to not be at the point of the bow, right? So maybe not stay put, because right now the worst of it's coming at you. If you have no other out, no other escape, you just know, I'm just going to have to let it go over me. At least, if nothing else, get yourself pointed toward the storm. That makes you much more aerodynamic. So as that big 70, 80, 90 mile per hour wind gust comes barreling over top of you, you're a lot more streamlined. The wind is kind of woof over top of you. Plus, if there's a lot of wind-driven debris or it's punching along this golf ball sized hail at 70, 80 miles per hour, at least your windshield is your strongest window. And so that way, hopefully it'll hold up a little bit better. So if you're going to stay put, get pointed at the storm. Could you potentially run a little further north? You're still going to get in the storm, but could you look for a place that's at least away from the bow for it to impact you? That's an option. Maybe you just run along this country road and you scoot up to Haven and you find a place, an indoor place to take cover. That's an option. What about if you decided to just floor it and take off and try to outrun the thing? If the winds coming out of it are 70, 80, 90 miles per hour, are you going to escape it? Yeah, probably not. All right, let's say that you're getting this prickly feeling on the back of your neck that I think we're going to have storms today. And you pull up your radar, and this is what you see, and you are the blue dot. Yeah. First of all, I kind of question your situational awareness. This is the first time you figure out there are storms. But are we in a safe spot? No. And what if you look in your rear view mirror and you see this? Which direction is that thing moving? If you put the storm in motion and this is where it's going, what does that mean the tornado's doing? That tornado's chasing you, yeah. So again, we're out in some foreign territory. We're way over by Strong City, and you're coming up Highway 150, headed toward Highway 177. You're like, that thing is right on my tail. First of all, is staying put a good idea? Probably not. Now, if it was a spindly little rope tornado, maybe. But that thing looked pretty substantial. So we probably don't want to just sit and let it run over us. Could we potentially make a bolt for Strong City and try to find a place to shelter? We could potentially. Yeah, probably better. And it actually didn't end up being an option. But if you could find a way to drop south, if there's a road right there, let the storm keep going to the northeast and drop south. Yeah, is going backwards an option? No, because you're running straight into that tornado. Yeah, bad idea. All right. Now, you're driving along. Let's say this is Highway 254 and you're on your way to El Dorado and you just kind of glance to your left. Well, what do we have here? And your first reaction is to pull over. Good call. And you're pulling out your phone. You're like, I'm going to check radar and see which way the storm is going. And you pull out your phone and no service. How do we figure out where the storm is headed and what this tornado is doing? Yeah, that's kind of one of the golden rules is if the tornado doesn't go left, it doesn't go right, it just gets wider. It's probably coming straight at you. But in this case, we've watched this thing, and what is it doing? It's going to the right, isn't it? So if you were to just stay put, and then we continue on and continue to watch it and continues to do that, are we actually in a safe spot? Yeah. We just sit here and get some good video and put it up on our social media and yeah. Well, now we got this situation. You're driving down the highway, 4-lane divided highway, and all of a sudden you look up ahead of you and you see this, and you see this on your radar, and you're like, oh, I got to put this radar in motion. I got to figure out which way this thing is going. And you're like, oh my gosh, I'm going straight. Oops, I forgot to charge my battery. So this guy, we're going to see what this guy chooses to do. Now, unfortunately, the sound quality is really low on this, but watch off to the right. There are subtitles.
And I cannot tell which way it is going, so I don't.
This guy he said, can't tell which way the tornado's going. So he's just going to sit there and watch it for the moment. Which way do y'all think it's going? Yeah. Do we have this whole it's getting wider situation going on? Because, yeah, it's going to come right over me.
Back up here a little bit and get under the bridge.
So his solution, instead of running away or going somewhere else, is he's just going to scoot backwards a little bit and get under the bridge. Good move, bad move.
I have honestly
bad move. So he's sitting there. He's like, well, I'm just going to watch it as it gets wider and wider and wider. That's right.
Totally crazy. It's coming right. It is coming right over the top of me. It's a little bit scary. I don't really.
Yeah. I don't really know what to do, except I guess I'll just sit here and maybe I'll duck down. So let's find out what happens. This is what ends up happening.
Ridiculous.
That is a big old tornado, isn't it? And you notice, remember we talked about the inflow winds? Look how everything is sucking straight into that tornado. He is really close to that thing. Oh no. It's all completely crazy.
The truck feels like it's about to lift up off the ground. Not lying.
And you can actually see the way the truck is bouncing. He got super, super lucky. That thing just grazed him pretty much. But now as he peeks his head out, and you take a look at his mirrors, it actually sucked his mirrors forward toward the tornado. So yeah, his solution of, first of all, his solution of going under a bridge, not a good one. Way years and years and years and years ago, the guidance used to be, oh yeah, crawl under an overpass, shelter from a tornado there. The problem with sheltering from a tornado under an overpass is you've got, remember, all those strong inflow winds. Even if the tornado isn't going directly over the bridge, you've got all those strong inflow winds sucking into the tornado. And now you've compressed all that wind to go underneath the bridge. So it's actually accelerating under the bridge. Plus, any debris that it's picked up, you know, you've seen Twister, right? Yeah, the tractor, the cows, all that is actually coming through that wind tunnel as well. So yeah, not a good place to be. All right, our last situational example is this one. Can anybody tell me what's wrong with this picture? Got another one where it kind of seems to be getting wider, maybe a little bit to the side. And you see, look at all that inflow. Is it just everything? Whoa, and there goes the playset. Everything's getting sucked into the tornado. Right now, the tornado is pretty much that entire width of the screen. It's that large. And where's this person standing? Yep, right by the window. Got some great video, but entirely exposed. Absolutely exposed. Yeah. What's wrong? Didn't take shelter, stayed and took the picture, stood in front of a window. Okay, so let's test how good you are at estimating wind speeds. Okay, when you can see it in the flashes, you see a little bit of the tree bending and stuff. Who would say that's 50 miles per hour winds? Okay, 60? Anybody? 70? Yeah, that one was just 50-mile-per-hour winds. Kind of unfortunate with the light over top of it. It made it a little bit dimmer. Okay, how about this one? Anybody want 60 on that one? Anybody want 70? Got some 70s? Anybody want 80 plus? And this actually, even though it says Australia Sky and Weather, it was Australian chasers who were in Wichita. So that is actually from the night of the 102-mile-per-hour gust. But this one happened to be 60 and 70-mile-per-hour gusts. How about this guy? Who says 70? Anybody say 80? Any 90s? That was a combination of 80 and 90-mile-per-hour gusts. So yeah, nice job on that. So now let's talk about reporting. Whether you are reporting because you are part of a public safety agency and you are asked to please report what you're seeing, or if you're a member of the public that you're like, okay, I see something, maybe I should tell somebody. You know, there are options for everybody to be part of the warning process. And when I say part of the warning process is, think about it from this perspective. This is what the meteorologists are looking at during severe weather. They're looking at their models, they're looking at their radars, they're looking at satellite, they're looking at all this instrumentation. They are not looking at the clouds themselves because they are bunkered down inside the weather center. And so they see all of this and they see potential. They see a storm that looks like it may be producing a tornado. They see a storm that looks like it could be producing baseball-sized hail or 80-mile-per-hour wind gusts. What they don't see is this. And this is what they need. They need those public reports, that verification of, are we reading this environment correctly? Is it happening the way we think it's happening? That ground truth is vital in helping them decide to either issue a warning or potentially to cancel a warning. Because if they've got a storm that's warned for ping pong ball sized hail and it rolls through Andover, and Andover Fire, Andover PD calls us and says, we got pea-sized hail. Is there really a reason to have that storm warned for baseball or for ping pong ball sized hail or golf ball sized hail? There's not. So yeah, it goes both directions, either helping them pull the trigger on a warning or cancel a warning. So if you are a member of the general public and you just want to give the Weather Service in Wichita a call and say, hey, I'm seeing this, you don't use this number to call them and say, hey, we've got a graduation this weekend. Can we please have nice weather? No, this is if you have a storm report. You can call their 800 number or you could text them. They do have a texting line. Now, this is not monitored for voice calls. So if you try to call this number, it won't do you any good. This one's just for texting. And if you text them, they like you to send pictures too. In addition to their calling line, their 1-800 number, and their texting line, they do actually monitor their social media during storms as well. So you can hit them up on X, you can hit them up on Facebook and send in your pictures of funnel clouds and hailstones. Now, if you're reporting to us, which most of the time that's primarily public safety and our volunteers, though we do get public reports as well. There's a few ways to report to our department because what we serve during severe weather, we're kind of that gathering point of all the storm reports around the county. So we gather information from our public safety spotters, from our volunteers, calls that are called into the 911 center. We gather all that information and then we have a chat room that we're in with the National Weather Service through the entire storm, and we're like talking to them in this chat. And we're relaying information saying, okay, our spotters in Towanda are now reporting estimated 80-mile-per-hour wind gusts. And they're like, check, got that, 80-mile-per-hour wind gusts. And so we're kind of that clearinghouse of information. On the flip side, we're also getting information from the Weather Service that we can pass on to our spotters. Things like, we're watching that storm near Leon and it's really starting to tighten up rotation. We're starting to feel like there could be some funnels produced soon. So we've got this ongoing conversation the whole time weather's happening. We do our public safety coordination on our EMA Ops radio channel. So you can always either just come over and listen on there or come on over and talk to us on there. If you are a ham radio operator, either our volunteers or members of the Flint Hill Amateur Radio Club, We'll have a weather net open. So if you're a ham, you can call in your severe weather reports on that net. You can call us on the phone as well. So we got a couple options. That 600-5447 number goes right into our emergency operations center. If you have our office number memorized and you want to speed dial that, there is an option to select 5 for the, I think it's 5, for the emergency operations center, which is where we do our severe weather operations if it's more significant severe weather. I will be 100% transparent with you. If a warning gets issued at 2 o'clock in the morning and they're warning for quarter-sized hail and 58-mile-per-hour wind gusts, I am not getting up and driving to the office to take your storm reports from the office. I'm going to sit in my recliner with my radar and my radio and my fuzzy bunny slippers, and I'll talk to you that way. So on those nights, that phone number is just going to ring and ring and ring. Now, we do have an X account and a Facebook account. We, however, do not really have the bandwidth to monitor that during active storms. So if it's something time-sensitive, life-threatening, please don't report it to us that way. Please share it directly through one of the other avenues. But if you want to share damage pictures after the fact, we always welcome pictures of the tree damage, the shed obliterated, all that fun stuff. You can give us that stuff. So let's talk about what is a good report. So a good report includes lots of details and lots of precise details. So describe what you are seeing. And more descriptive than just, I have really high winds and heavy rain. I don't know what your definition of heavy rain and high winds is. So more specific and compare it to something. So if you see a funnel cloud, if you see a tornado, describe it as that rope or that stovepipe. If you have heavy winds or high winds, estimate it. Is it estimated 50 mile per hour, 80 mile per hour? If you have hail, what does it look like? Is it a quarter size? Is it a baseball size? If you're not reporting now, something that's happening now, if it's a delayed report, be sure to let us know. Hey, by the way, this actually happened 20 minutes ago. I was just delayed letting you know. And then the where is very, very important, because if you call in a report and say, hey, I'm at the corner of Andover Road and Pawnee, and I've got baseball-sized hail falling, I'm going to assume you and the hail are in the same place. However, if you call in and you're like, yeah, I'm up by KMC and I've got a massive wedge-shaped tornado, I really hope you and the wedge-shaped tornado are not both together at KMC. So being specific about, well, I'm standing out in the KMC parking lot and I'm looking toward the east, or I'm looking toward the north toward Benton, that's very helpful. That's very descriptive. And then I don't assume that you and a tornado are kind of doing a dance. And then if you're doing it over social media and you're trying to direct it to the National Weather Service, be sure to tag them, use the @NWS Wichita or their hashtag KSWX. So let's talk about a good report. So this is an example of a good report the Weather Service liked. So somebody sends them this picture. They say, we have a large wedge-shaped tornado located 3 miles south of Sylvia, moving northeast toward Plevna, picture taken at 11:50. Great information. There's a picture. It's very descriptive about the what, the when, the where. It even tagged the office because they're on social media. They love that. This report, on the other hand, is one that for the Weather Service is like fingernails on a chalkboard. I got marble-sized hail, which seems like a very reasonable report, right? Except for if you ask the Weather Service, they're like, they are multiple sizes of marbles. We don't know which one you mean. So don't use marbles. Use something else like money. They love money, quarters, nickels, dime size. They like fruit, grapefruits, ping pong balls. They like balls, tennis balls, softballs. So use something a little more consistent, something that's has a lot of variation. Like your child's head. I don't know how big your kid's head is. So, or your chihuahua. I don't know how big your chihuahua is. So, okay, let's look at another report. Had some large hail near El Dorado. What's missing from that report? Yeah, near El Dorado is not very specific. Can you really tell the size of that? Who's got kids? The banana for comparison? Or anybody know that? Has anybody heard that trend? You put a banana next to everything. Oh, yeah. The banana for comparison. There's no banana in the picture. We don't know. So yeah, there's nothing to really show how, because this could be really zoomed in on pea-sized hail or really zoomed out on baseballs. So that's, yeah, not the kind of detail we need. Now this is super specific. Now we've got a ruler. We've said it's 2-inch hail. It occurred about 10 minutes, started at 8:30, and zeroed in at the intersection of Summit and Central in El Dorado. Now, I'm okay, actually, if you just tell me if it's happening in the city, to just say it's in the city of Andover, or it's in the city of Augusta. Intersections are helpful, though, if we're out in the county and you're like, I'm at Southeast 170th and Coal Creek Road. That's good details. How about this one? There was a large tornado 2 miles to my north around 8:15. First of all, is this a large tornado? Or is this maybe adrenaline and, oh my gosh, it's a large tornado? Yeah, not really a large tornado. So in the moment, it could be just excitement. But if you're also trying to create drama, like, I got a large tornado, huh? Yeah, you don't want folks that are gathering your information making decisions off of your report of a substantially large tornado, and then we find out you had a landspout. Yeah, so it does have the time. How about this? Instead, we say a brief tornado occurred about 5 miles west of Latham at 8:15 this evening, and the tornado was on the ground for about 30 seconds. Very good, detailed, and actionable too, because now we have a better understanding of the risk associated with it. We're not thinking there's this big wedge about to eat Latham. Okay, so that's all we have on the reporting. Any questions about reporting? All good? Okay. So we'll get into we're kind of toward the end stretch now. We're going to really start narrowing in on what are our protective actions we can take during storms to be safe. So first of all, a disaster kit is always a good thing to have. We helped you get started by giving you whistles tonight, because blowing whistles is always, if your house gets obliterated above you and you're trapped in your basement, a whistle is much easier to hear than help, because your voice wears out. Shoes are actually a wonderful thing to have in your kit, because if the tornado does go through your house, what's left of your house? Sharp glass, nails, splinters of wood. So yeah, have those.
Susan, get my pants.
And if you hear that guy in the background, the critical piece is always have pants. So make sure that's either in your emergency kit or even more preferably on your body during the storm. So let's talk about lightning. So you guys have heard the flooding, the thing they say for flooding, turn around, don't drown, that little catchphrase. They have one for lightning now as well. When thunder roars, go indoors. It's clever, huh? The reason they use that is that they want to make sure people understand that lightning can strike well ahead of the body of a storm. So if you are able to see the flash or hear the crash, you need to assume you're probably close enough to get hit by the lightning. So those are your signals that I need to get indoors, because the best place to be during a lightning storm is inside a building. Get inside, take cover. Now, if that's not an option, let's say you're out driving, you can be safe if you stay in your vehicle. So if the lightning's flashing all around you, just stay put. Just wait for it to pass. What you don't want to do is you don't want to be outside, and you especially don't want to be the tallest object, because that's what lightning heads for, or be standing under the tallest object like a tree, because what does lightning go for?
Right near the 18th
It likes
green
trees.
again. Our lock cameras caught that bolt. And let me just tell you, it wasn't too far.
This one actually does start a fire. And then how about this guy?
Gosh, dang it. My Prius literally just conked out at me from that lightning strike. It's not turning on. Look at the antenna. I have a tutorial installing that thing and it's just blown off.
Recording at 4K 60. So you can clearly see the plasma dissipating into the air. Not to mention my antenna being vaporized. Plus, look down here. You can
and look at
even
it coming
see
out of the
points
tires.
around my tires. It traveled.
Lake, Point, Maple Hill, Emmett, Tavia, and Willard. Tavia and Willard.
Yeah, that's some powerful stuff. We definitely don't want to tangle with lightning. So winds, and this specifically is referencing severe winds, but I kind of want to put severe winds and tornado winds together because really, when it gets up there in those speeds, 100 plus miles per hour, even before that, it doesn't matter if it's going straight or it's spinning. It's going to cause damage. It's going to hurt you if you're caught out in it. And one of the things that doesn't mix at all with severe wind, whether straight or twisty, is outdoor activities. So if you're out boating, if you're out camping, doing any kind of thing outside, you are at risk from winds. And so what we want to make sure you do is if you are going to have an outdoor activity planned on a day that Mother Nature is also making plans, to be sure that you have thought through what you're going to do if the storm approaches, especially if you're in an area removed from buildings. Is there a storm shelter somewhere nearby? Like, does the campground have a storm shelter? Are you even in an area with cell phone signal where you can get the warnings, get the watch information? So think that stuff through before the big storm clouds rolling over top of you. Something to keep in mind, because again, we said way at the beginning that the tornadoes get all the press and all the publicity and all the attention and all the glory. But if you look back at our recent weather records, the last 2 fatalities in Kansas associated with storms were severe wind or straight line wind deaths, not tornado deaths. One being in 2009, there was the super derecho that went through, and down in southeast Kansas, 80 to 90 mile per hour winds killed someone. And then in July of 2024, there was a storm that went through Wilson Lake through the campground, and there was a fatality, 65 to 70 mile per hour winds. This wasn't 140, 180 mile per hour tornado winds. And of course, keep in mind last year, that Bo Echo storm that produced a 102 mile per hour wind gust, which that's like EF1 tornado damage. I mean, that's EF1s do the kind of damage like in those pictures on the left. When you're dealing with severe wind and you're thinking about taking shelter, we'll talk about what to do on the road with tornadoes here in a little bit. But if you're sheltering in a building and severe thunderstorm wind producing storms or tornadic storms are coming through, and you're thinking, where do I shelter? First of all, staying put in a mobile home or manufactured home is usually not a good idea. Those get splintered and rolled pretty easily. So we don't want to stay in those. We also don't want to be in a really big, expansive, like a gymnasium where the roof can get peeled off and everything gets sucked out. So avoid that too. But we want to get to the lowest level possible. And that's for straight line winds or tornado winds. We want to get you guys low. If you have a basement, love basements. You have a FEMA storm shelter, love those too. Don't have the option for either of those, but you're in a well-built, stick-built building, go to the lowest floor as interior as possible. We want to get away from windows. We want to get away from exterior walls. You basically want the storm to work at it to get to you. A lot of stuff it has to eat through to get to you. So interior, something cozy like a closet or a bathroom. And obviously, windows will shatter whether it's wind going straight or wind that's spinning. So let's talk about hail, because that's another thing that can cause a whole lot of damage. Yeah, a lot of our storms, they're nickel-sized hailstones. They're quarter-sized hailstones. But you get the bigger ones, and those things can shatter windows. Those things can actually punch through roof decking. So if you're outdoors and have the ability to get indoors quickly, and then get away from those windows, get away from those exposed walls and ceilings. If you happen to be outdoors, a lot of hail accumulating on the road actually can become as slippery as snow or ice. So we do want to get pulled over if a hailstorm gets us while we're driving. Stay in your vehicle and just kind of get pulled over, get safe, let the storm pass over you. Oh, and please don't use those overpasses. We said don't use them for tornadoes because of that wind tunnel effect. Try not to use them for sheltering from other forms of severe weather as well. Because as soon as you get the bright idea to pull over under the bridge, the next guy gets the bright idea, and pretty soon everybody is, the medians are the shoulders all full. And so the next guys are like, well, I don't want to be in the hail. So then they take the first lane of traffic, and then they take the next lane of traffic. And pretty soon you got congestion clear across the highway. Miles of traffic is backed up. And if this were a extremely heavy rain producing storm and we've got torrential rainfall coming down and the people way back there cannot see that all the traffic is standing still because you and your friends wanted to be under the bridge, we can cause a big pileup. You can't get emergency vehicles through. Just creates a mess. So, moral of the story is bad. Don't do that. All right, so let's look at some severe hail.
Coming in this way too. Windshield's gone.
Yep. Dude, it's gonna take out the front one too. Crap. Yeah, it's gonna take out the front. Oh man, check that one too.
Crap. Count to 10 slowly.
Now hold it.
Count to 10.
I'm just looking at the time.
And look, that's all glass in his lab. And in a minute, he's going to actually show you his arm is actually getting cut up by the glass too.
There's blood here.
Big wounds. So after our experience last year with that, especially with the June 3rd flooding that happened, particularly impacted like El Dorado, the Wagon Wheel area, we wanted to put a little more emphasis on flood safety this year. It's floods, especially flash floods. Now, last year was a combination of both flash floods and river flooding. So we had all kinds of floods going on. But flash floods in particular can be extremely sneaky. They can come up really fast. They can hide exactly how fast they're flowing. They can hide how deep they are, and they can hide the damage they've already done. They could have already eaten away bits of the road. And if you just plow into it and assume, well, I know where I'm going. I just need to get from here to there. I'm fine. May not be a road there anymore. And keep in mind, too, that you may not make it through because that water can float you pretty easily, too. If you were walking through it, it would only take 6 inches of fast-moving water to actually knock you off your feet and sweep you away. If you were in that guy's Prius, for example, that one maybe only would take about a foot of water to wash you away. You got something a little more substantial like a truck or an XUV, it may take up to 2 feet of water, fast-moving water to sweep you away. But yeah, once you get flowing, you can hit those brakes. You're not stopping. So in preparing for floods long before they happen, if you're in an area that's prone to flooding, you probably already know you're in an area that's prone to flooding. You probably know where the water tends to accumulate. If you've got a low water crossing that somebody flushes their toilet and there's water over the road. But keep in mind too that sometimes we have events we don't anticipate. Like in El Dorado last year, there was floodwaters rising and going into neighborhoods that we weren't used to seeing floodwaters rising and going into neighborhoods. So just because it hasn't flooded around you before doesn't mean that it can't. And so if you haven't looked at maps to see where you are in relation to a floodplain, that's always a helpful thing to do, especially if you're trying to map out in your mind, if a significant flood happened and I needed to evacuate, how do I get out of here? And especially if you're in an unknown area, an unfamiliar area, and there's forecasted heavy rainfall, floods, that kind of thing, inquire of the locals. How do we get out of here? Where does it flood? And then if a flood is occurring, stay out of the water, first of all. I also recommend don't wait. If you're starting to get that feeling that, okay, there's a lot of water flowing, there's a lot of water rising, I know my neighborhood's going to get cut off if we get past this point, and you feel that you may need to evacuate, don't wait for an official recommendation from the officials to say evacuate. get yourself out, because some of these warnings, especially related to floods, can be very reactive rather than proactive. We may get a flood warning or a flash flood warning based on the NWS saying, okay, we've already had 3 to 4 to 5 inches of rain falling over that area in the last hour. Probably flooding, let's issue a flood warning. Or like we had last year, they actually went as far as a flash flood emergency in El Dorado. But a lot of times that trigger gets pulled because they're getting all these reports of, we got water over the road here, we've got submerged vehicles, we got water rescues going on. If we're to that point, and that's when we're pulling the trigger saying, okay, we've got to evacuate the entire north half of Andover, it's probably too late to get out. So don't wait for that. All right. One of the things that is I like to promote, now it's a little different here. I'm not sure how that would affect you in the city, because you guys are actually in a different 911 center, or serviced by a different 911 center than the county. But just so you're aware that this is out here from County 911, is we do have a system called Rave Alert. It's a mass notification system that is used to do targeted notifications. So we don't use this to push out the severe thunderstorm warnings, the tornado warnings. But if, like in the example of the El Dorado flood, and we had to evacuate portions of El Dorado, they use this system to push a mass notification out to a defined area and say, okay, evacuate from this to this to this to this area. The downside of our system is we cannot automatically capture everybody's phones with this system. People have to self-enroll or self-register their phones. Once you're registered, though, if you fall within if your residence falls within the area that's affected, you get the alert. So if it's something you want to look into, again, it's a little weird situation here in Andover because you guys have your own 911 center. But if you want to look into it, you just go to the county website and under departments, choose emergency communications, then choose the 911 self-registration, reverse 911 self-registration, fill out the little form, and then you're enrolled. This is an example of just how quickly flash floodwaters can move and rise. This one is not sped up. That's real-time water right flowing. This next one is sped up, but again, just the image of the volume of water that can come through in a flash flood event.
There's people in it. Oh my God, there's so many people in it.
Yeah, so all those were from the Texas floods last year in Hill Country. Very bad floods. So I did tell you we'd come back to what do you do if you are caught in a tornadic storm and you're in your car? Well, we've got a couple of different things to keep in mind. Back to that, don't go under an overpass. First of all, stay away from the bridges. If you can safely outrun the storm, so if you can see on radar and you can see your position and you know the storm is going to go this way and you have an out going this way, outrunning the storm can be an option. If you have a place you can pull off to and take shelter, like a business, a restaurant, something like that, get off the road, get into shelter. Last resort, if you cannot outrun the storm, if you cannot find shelter, there has been a change over the years in what the Weather Service recommends. Do you remember back in the days where they used to say, get out of your car because, if the tornado hits your car, it's going to crunch it all up and throw it. So get out of your car, go in a low-lying area or a ditch and wait for the storm to pass. Okay, they don't really say that anymore. They found some problems with that because if you are lying in this ditch and it's a heavy rainfall producing storm, we might drown you instead of kill you by the tornado. Also, now you are outside of the vehicle and exposed to all the debris that's flying, everything that's getting tossed around. Way back at the beginning, we said 95% of our tornadoes are EF0s, EF1s, EF2s. Most of our tornadoes are super survivable. So if it's not big monstrous EF5 that's about to eat you, most of those low-end tornadoes, you could ride them out in your car. We just recommend that you get buckled in, you hunker down, get your face below the level of the glass, and just try to ride it out.
And if you look closely, you can actually see there's a man in this car.
So, pretty nice to breathe, Bill.
Anybody recognize that tone? You heard that before? So that's, most people equate that with the Amber Alerts. I'm just going to get past it to make it stop squealing at you. This is definitely an excellent notification system when we have extreme weather. So the idea behind the wireless emergency alerts was that this would come pre-installed on every phone. Now there is the option to turn warnings off or alerts off, so you might want to double check you haven't accidentally done that. But you don't have to download anything, install anything. You automatically have this on your phone, as long as it's not a flip phone from the 1990s. But you know, the current phones, you've got these wireless emergency alerts, and the idea behind them is if you are in a spot where the Weather Service has drawn the warning polygon and you're in the threat area, when they trigger these WIAs, you should get the WIA on your phone. Now, originally, they only had a handful of weather threats in them. They had tornadoes, they had flash flood warnings, they had like tsunamis that don't really apply to us, hurricane-related stuff. But they did not have severe thunderstorm warnings in them initially, because we get so many of them that they were afraid people would start shutting these things off. The more they thought about it, though, they said, you know what? We get these high-end extreme thunderstorms that are very life-threatening, and we do have to put those in there. So now, if the storm is being warned for 80 mile per hour or greater wind gusts, or baseball-sized hail or larger, or both, you will get those WIA alerts. However, if it's warned for less than that, you're going to need another source of information because the WIAs won't go off. So make sure you have some other source of info. And speaking of info, I've got one little bonus I added in here. Has anybody spent any time on the Storm Prediction Center's website? Yeah? So you've gone out and looked at the convective outlooks. If you're one of those that likes to go out and look at weather information ahead of time and kind of get a feel for yourself, do I have a weather risk developing today, tomorrow, 7 days out? And you like to start to see where do they think the targets will be and how extreme do they think the hazards will be? Will it be tornadic? Will it be hail? Will it be wind? The Storm Prediction Center has this thing called the convective outlooks that's really cool because it's very colorful, creates all kinds of these neat bullseyes. Well, this month, they actually made a very substantial change to these convective outlooks. The one on the left, that is actually what their bullseye looked like the day of the 2022 tornado. So this was trying to estimate where the highest probability of severe weather was. You got your light green, which was just garden variety thunderstorms, and then the further into the bullseye you got, the higher the probability, the higher the risk. And so it went from garden variety to then it was marginal, then slight, then enhanced, then moderate, and the highest level you could get is high. With the update, so this is the other one over here on the right is from that first week of March, one of those storm days. This one, as you can see, they've tried to simplify the image. They took away the words, so we're not cluttered up with words, and it's more of a visual thing. As you can kind of see, oh, there's the bullseye, and then instead of using terms like moderate or slight, that doesn't necessarily mean things to people, they still have them there, but they're focusing a lot more heavily on the numbers. So if you're in the red, your threat or your probability is a 4 out of 5, which sounds a lot more significant than we're in the moderate today. Okay, I don't know if that's bad or not. I'm moderately impressed by that. But the other thing they did is I think it's for the first 3 days, because they have these outlooks for 8 days out. And when you look at day 1, which is today's, and then that's day 2 and day 3, they will also drill down to specific hazards. What is your threat of tornadoes? What is your threat of hail? What is your threat of wind? And then they'll try to bullseye where are the highest probabilities. Again, the one on the left, that was the tornado threat for 2022. And you can see the tighter you got into the bullseye, the higher the probability was that you were going to have some kind of tornado. And then they had an option to either say just the color or the color and hatch marks. Hatch marks meant that not only do you have a probability, but you have a probability of high end, like big tornadoes or big hail. But it was just kind of an either or. Either it's low end stuff or high end stuff, but it's never really quite that black and white. So now what they've done is you look at the one on the right for that same day a couple weeks ago, you still have the increasing probabilities. You're still creating the bullseye, but now they have a series of different hatch marks. So if you get for like, and it's for tornado, hail, or wind, if you look at tornadoes and you've got, let's say you're in the 5% probability, or let's up it, 10%, which in meteorological terms is pretty high, 10% probability, but all you got is the little dash marks, that sig 1, that means, yeah, your probability's up there, but the intensity of the storm is going to be low. It's going to be those EF0s, those EF1s, where at the bottom, if you have a probability of 5%, which doesn't seem like a lot, 5% is not so bad, but they've got the X's, those kind of marks. That means that, okay, maybe your probability is not high, but if it happens, the intensity is going to be significant. We're going to talk like EF4, EF5 tornadoes. So it gives them a lot more leeway to explain to you how big, how bad. For the weather geeks, this is really cool. I was very excited. If you want another way to report stuff to the National Weather Service, there is this thing called CocoRaHS that lets you get a rain gauge and you can record precipitation and you can get on a website and be part of their reporting network. They just asked us to plug that as well. And the last thing I want to plug to you is every 3 to 4 years, the National Weather Service will do what they call an advanced storm theory, where they get much deeper into the science. So if you really geek out on the science side of this stuff, this is the year they're doing their advanced. And even cooler is we got to host it in Butler County, and it's going to be right here in Andover, over at the Lodge, Thursday evening, April 9th. So put that on your calendar. Come get some really serious weather science. And that is it. You have survived your severe weather training for this year. So thank you very much for your attention. I really appreciate you coming tonight. And everybody be safe this season.
You did a great job. Thank you.
Thank you.
Get out. Yes.